Hello Matrix and welcome again. Today we are carrying on with finding the derivative of a function. So for all of these you just need to know the power rule, and then it's just a bit of algebra to get the function into the form that you want it to look like. So remember the power rule says that, say we have a function 3x cubed. To find the derivative of this, we multiply the exponent by the number in front, which is 3 times 3 is 9. And then we just take 1 off the exponent. So 3 minus 1 is 2. So it would just be 9x squared. So all of these questions are, you need to get it into this form, where it's ax to the n. So in other words, 3x to the 3 or 2x to the 2, something like that. So it needs to be in that form. So a lot of this is just straight algebra, and then just using this, the power rule for differentiation. Now, when they say dy over dx, that means that find the derivative. So for the first one, we already know that the derivative dy over dx of 3x cubed, we've done it above, is 9x squared. 4x squared, well, 2 times 4 is 8. 2 minus 1 is 1. And then when there's a pi is just a number. So if you see ex or pi x, those pi and e are just the same as just a straight number. So we would just say plus pi, because if a number, if x only has an exponent of 1, then the derivative is just whatever is sitting with x. And then finally, c does not have an x, so that'll be just fall away and become 0. So that's the first one. Question 2. Well, we don't have it in the form of y equals yet, so we need to do that. So for question 2, we're going to take out y as a common factor. And so y, when we take it out on the left-hand side, it becomes yx minus 1 equals 2x squared minus 2x. Now to get y by itself, we divide through by x minus 1, divide by x minus 1, and we get y equals, and the x's cancel. Now, when I take out 2x on the top, I'm left with x minus 1. So 2x out of here leaves x, 2x out of here leaves 1, over x minus 1, and these cancel, leaving you with y equals 2x. So I haven't even differentiated yet. I'm just making it in the form of y equals. Now the derivative's easy because x doesn't have an exponent of more than 1 or less than 1, so I can simply just say that dy over dx is equal to 2. The next one, it's not quite in the format that we want because it's x is at the bottom. So for 3, what we want to do is we want to take that x to the minus 2 across. So we're just going to make it 2x to the minus 2. So the x to the 2 goes top and becomes x to the minus 2. This here, we remove it, so we know that that is simply x squared. But now it's to the root 3, which means over 3. If you're not sure about that, check out your exponents. This is an exponents question more than a differentiation question at the moment. Now that we've got it into this format, we simply use that power rule. Minus 2 times 2 is minus 4. X minus 2 minus 1, minus 3. 2/3 times 1 is 2/3, and when I take 1 off 2/3, I get minus 1/3. Not quite finished yet. So this now I say dy over dx. Now I just need to get rid of negative exponents. So I say negative 4 over x goes to the bottom, becomes positive 3. 2 over 3, x to the minus 1/3 goes to the bottom and becomes plus 1/3. I could also put that as root 3, but I'm going to leave it like that. So that is the answer. So dy over dx for the question 3 is this. Now let's look at 4. And so here what I've got is a square there. So if I was doing AP Maths, I could do the inside-outside rule, quote chain rule, but that's a little bit difficult for the matrics who haven't done AP. So I'm just going to multiply it out. So x squared minus 1 over x squared. And so we're not doing anything that you haven't done before in like grade 10 even, maybe even grade 8 and 9 if you start with this sort of multiplying out brackets early. X squared times x squared is x to the 4. When I multiply x times 1 over x squared, I get 1, and there's 2 of them, or minus 1, and then another one here, another minus 1 when I times these two together. So I get minus 2, and then plus, when I times this last 2 together, I get 1 over x to the 4. Okay, and now I'm just going to carry on over here, x to the 4 minus 2 minus, and I'm going to take the x to the 4 to the top and become x to the minus 4. Now I can just use my usual dy over dx, x to the 4, that's a 4 here, 4 times 1 is x, take 1 off the 4 to become 3, 2 goes away because there's no x, minus 4 times minus is a plus, so it becomes plus 4, x to the minus, and now it's 5 because I take another one off here when I'm finding the derivative. And finally, what I can do is just tidy it up because I don't want negative exponents, so the x goes to the bottom and becomes x to the 5. Okay, so those are some derivatives. If I went too fast, I think maybe I did for question 4, just go to your settings on and just slow the video down, and it actually just, you can watch it in a slightly slower mode if you want, or just rewind and try and watch it again. But hopefully that helped. If it did, please subscribe, like, and all that good stuff. And I will see you in the next lesson where we're going to be doing a few more of these examples, but I'm going to show you the different notations they can have, because the notations sometimes confuse you, which they shouldn't, because it's all just doing the same thing, which is finding the derivative. So I'll see you in the next lesson.